Hey everyone, welcome. Today we're going to dive into a really simple experiment, but it's got this massive lesson baked into it. It's all about how our best intentions, trying to fix every little problem, can actually be the very thing that makes the whole situation worse. Kind of wild, right? Let's get into it.
I mean, just think about that for a second. It kind of goes against everything we've ever been taught, doesn't it? See a problem, fix the problem. That's the mantra. But what if that instinct, that constant need to jump in and correct things, is actually the source of more problems?
So yeah, that's the big paradox we're going to tackle today. We're about to see how all that over-adjusting, all that tampering with a process that's already stable, well, it doesn't lead to precision. Nope, it leads to chaos. And the proof is it's in this wonderfully simple, elegant demonstration. All right, so the key to cracking this whole paradox, it comes from the work of a guy named Deming, absolute legend in the world of management theory. And he used this super simple funnel experiment to show a massive, and I mean massive, point about how systems really work. A point that, honestly, most of us miss all the time. Okay, so the setup here, it could not be more basic. Seriously. You've got a funnel, right? It's held over a target on a piece of paper. And you just drop beans through it, one by one. The goal? Super simple. Hit the bullseye as many times as you can. But here's the kicker. The magic isn't in the funnel or the beans. It's all about the rules you follow while you're dropping them. And this is where it gets really interesting. We're going to test out three completely different approaches, three different rules for how we manage this funnel. And you should really think of these as three different management styles for running, well, pretty much any process. Could be a factory floor, could be a marketing department, doesn't matter. Okay, rule number one, super simple, the hands-off approach. You aim the funnel right at the center of the target, and then you don't touch it, ever. Again, no matter what. You just drop the beans and let the system do its thing. This is our baseline, our control group. All right, now for rule two. We'll call this one the chase the mistake approach. This is all about reacting. So let's say a bean lands 2 inches to the right of the target. What do? You move the funnel 2 inches to the left, but, and this is key, you move it from where it is right now. You're literally chasing the last mistake you made, and you completely forget where you even started.
And finally, we have rule three. This is another type of reaction, but it's a little different. So again, if a bean lands 2 inches to the right of the bullseye, you move the funnel 2 inches to the left. But this time, you move it 2 inches to the left of the bullseye. So you're always adjusting, but you're always coming back to that original center target as your reference point. So there you have it, 3 strategies. One is totally hands-off, and the other 2 are super reactive, always making adjustments. The big question is, what happens? What do you think happens when we drop, say 30 beans, using each of these rules? Seriously, before I show you the results, just take a quick guess. What's your gut feeling? Is all that constant correction in Rule 2 and 3 going to pay off? Or is the do-nothing approach from Rule 1 going to come out on top? What do you think? Okay, ready for this? The results are, well, they're dramatic. It's not even close. With Rule 1, the hands-off one, the beans form this nice, tight, predictable little cluster right around the bullseye. Exactly what you'd hope for. But with Rules 2 and 3, oh man, the constant adjustments just create total chaos. The beans are flying everywhere, scattering all across the page, and it actually gets worse with every single drop. It's a mess. And if the visual wasn't enough, the numbers just seal the deal. Look at this. After tons of trials, Rule 1 consistently nails over 11 hits on the bullseye. Pretty good. Rules 2 and 3, they barely manage 3.5 and 2.5 hits. Barely. And check out the hits way out in the outer rings. They just skyrocket with the reactive strategies. I mean, the data is just undeniable. So, okay, this brings us to the most important question of all. Why? Why does this happen? Why does trying to correct every little thing lead to such a disaster? Well, the answer comes down to a concept that Deming called tampering.
So what is tampering? It's basically when you react to the normal, natural ups and downs of a system, like each little blip is some 5-alarm fire that needs to be put out. Think about it. The system itself, the funnel, the beans, gravity, the air, it already has a certain amount of natural randomness built right in. It's just part of the deal. When you start adjusting for that randomness, you're not getting rid of it. You're just piling more randomness right on top. You're making the noise louder.
And to really get this idea of tampering, you have to know there are two different kinds of variation. First, you have common cause variation. This is just the natural built-in noise of any system. No two beans are perfectly identical, there are tiny little air currents. It's just part of the process. It's predictable over the long haul. Then you have special cause variation. This is something external, something unpredictable that messes with the system. Think of someone bumping the table while you're dropping a bean. That's a one-off problem you should definitely fix. But the common cause stuff, you gotta leave it alone.
And that right there, that is the absolute core lesson. The huge mistake in Rules 2 and 3 is treating every single bean drop, which is just experiencing that normal common cause variation, as if it were some huge special event that needed its own unique correction. And this is exactly what managers do when they freak out about every daily sales number or react to every single minor customer complaint without ever looking at the bigger picture. They're not helping. They're tampering.
So what's the big takeaway here? Simple. Stop chasing every single data point. A leader's job isn't to micromanage every individual result. It's to step back and improve the system itself. For our little experiment, what would that look like? Well, maybe it means getting a better designed funnel, or using a shorter string to reduce sway, or even just training the person who's dropping the beans. You see the difference? You work on the system, not in it.
And that really leaves us with one last thing to think about, a question to take with you. In your own work, in your projects, maybe even in your personal life, where are you tampering? Where are you constantly adjusting and reacting to all the noise when what you really should be doing is taking a step back, understanding the whole system, and making a real, lasting improvement? It's a really powerful question to ask yourself. And luckily, the funnel experiment gives us a super clear way to start finding the answer.